After last tutorial, our model had a map, topography, a cross-section, and boreholes. I'll edit the map. We can turn on and off the nodes with Hide Show Nodes. The top right also shows move and zoom controls. The options and the operations are at our left. Options allow us to view references in the geology or view other information. Operations modify the geology. Polygons represent units, lines, faults, and nodes are handles of polygons and lines. Select geological unit and click Add or Change Units to change the color of the geological map. Create a new unit appears if we select nothing. Select Flim Flon to modify its color in the form. Click the color input for color picker to appear. Click below the color picker to select the color from the chronostratigraphic chart. Then click an edge to close it. After you submit, the color of the unit changes in the list and also in the map. Fast forwarding, I have changed all the colors to make them look more like the map in the references. This is a stratigraphical map, but the most important for us is to model the ore body. In geological unit, we'll click the region of the ore body. I already knew where the open pit was, but later we will get information from the properties loaded, like lithology. We can look at the right and the units will be there. The ore unit was not in the map that has been automatically loaded from our stratigraphy boreholes. Geomodelr does not assume what units are, so you can use anything that makes sense. Click Line Operations. Line names were not imported, so we will name the most important. Select the name of an operation, then click the line you would like to name. We will enter the name in the text box in the right. I'll finish naming all the important faults. They will be used when we edit the cross sections. Back in our study page, let's upload an image of an interpreted seismic line. After it finishes, click Operations with Files. The image is a PNG. Click Georeference an image and the image to start. If the image is not in the same coordinate system as the model, you need to select a coordinate system. To georeference, pick at least 4 points. Geomodelr uses least squares to find a projection. Fill XYZ for the 4 corners. The coordinates of the points are in this image. When you click Submit, Geomodelr georeferences it in 3D. Back in the study page, select the cross-section. The editor is similar to the one of the map. Select Options Exaggeration to exaggerate coordinates above or below the sea level. Select References to show extra info while hovering, like object information. For locations, we can use pointer position or the grid. Click Select Reference Point and then the editing area to enable angle, horizontal, vertical, and total distances. References also work in the geological map that we can view on top of the section. The image layer shows a background image. Click Add More Layers, Manage Background Image Layers, our Line 125 image, and Submit. The image is projected to the cross-section and can be viewed if the background is transparent. Vector layers can be used to view boreholes. Click Add More Layers. In Dataset Projections, select the stratigraphy borehole's name and maximum distance to cut boreholes. Click Submit to create the vector layer. We add 10, 20, and 50 meters distances. The distance cuts the boreholes around the cross-section and then projects them to it. We can use different distances depending on the geological structure. Layers opacity makes a layer transparent, so you can view others. If you haven't assigned a unit to a polygon, it shows it as a bit transparent. To adjust transparency, you just need to move the slider of the layer you are interested. Polygon operations modify units. The most important operations are divide and join. Divide divides a polygon in two. Both polygons will have the same unit and properties as the original. Click an existing node in the boundary of the polygon. Continue clicking nodes until we reach another node in the boundary of the same polygon. If the arc you drew cut the polygon, the operation ends. To understand the operations, imagine you are cutting a donut. You finish cutting it when you separate two handles. The opposite operation is join. Join takes two polygons and converts them into one, with properties and unit of the first polygon clicked. Geological unit assigns a unit to a polygon. To wrap up polygon operations, if you are unsure about the operation, the green message on top says what's needed. Moving the pointer to an error position shows a red message. Geomodelr won't let you create polygons that intersect themselves or other polygons, or create voids in your geology. When you are dividing polygons, you need to create the boundary nodes previously. We'll learn how to add them later. The next operation is polygon properties. First, select a polygon. Then write the name and click the plus button. Write the property value when the box appears. You can remove a property by clicking the minus button next to it. Let's continue to line operations. Lines can't cut themselves. If you can't have a single fault, that's a branch, and they can close into loops. Line operations represent faults. In 3D, they should separate a solid geology with the surface. The add operations creates a line. Clicking a node or a position inside the cross section to start adding it. Click as many points as needed for the line. Finish the operation by clicking the last node created. Lines can intersect. They can separate polygons or lie inside them. The next operation is extend. For this operation, click an end node of a line. Add other nodes or the end node of other line. Separate splits the line into two by the clicked node. Remove erases an entire line. Just click it or near it. A name can assign a name to a line. Only named lines will be interpolated. Properties work the same as in polygons. Add and edit their values. Finally, node operations. Nodes don't have any geological meaning. They are the handles of both polygons and lines. Add creates a node in an edge of a polygon or a line when clicking it. Move changes the position of a node. Click a node and then click its new position. Join takes a line node and joins it with a node of a polygon. Separate is the opposite of the join operation, creates two nodes from one. And remove eliminates a node from an edge. Node operations are important to divide polygons or to make lines and polygons compatible. Let's delimit the ore body interpreted from the seismic. First, let's make the geology more transparent so we can see the seismic. Let's get closer to the region. Pick the 10 meters layer, as this needs to be modeled with more accuracy and the boreholes at more distance hide the ore body. Let's select Polygons Operations Divide. Another way to divide a polygon is to click inside the polygon and add nodes to close the loop. You cannot click outside the polygon or in a node that's not the first of the loop. To assign the ore unit to the polygon, click the geological unit, the polygon, and the end unit. Let's make the layer more opaque to review our cross-section. Right now, you have a solid model defined over the entire box of the model. You can interpolate or simulate with it. In next tutorial, we will see how interpolations make our lives easier.